Hi everyone. Thank you for coming back to Satellite Sundays with the Harvard Satellite team. Today we'll be talking about STK, which is also known as Systems Toolkit. So what the heck is STK? Why am I even talking to you about this in the first place? So, really good questions. STK is a software which is produced by Analytical Graphics, used for modeling behaviors/motions for satellites, ships, planes, missiles, vehicles, or about anything that moves. You can model sensors too, communication mechanisms, route planning, radars, so much more, and so much more than anything you can imagine. So the software itself is often used for mission level modeling, where you can analyze and visualize, always love pretty visuals, the individual components or groups of objects in the simulation that you're trying to model. So in our case, on the Harvard Satellite team, it put many things into perspective for us in terms of how our satellite would be able to communicate with the ground station. Also looking at orbital modeling, which is just seeing where the location of the satellite will be depending on where it is in its orbit. And also just how solar power generation would look like for a small CubeSat. So let's look at some of these examples in a bit more detail. The first is ground station access. We just want to check, can the small CubeSat talk to us in Cambridge? So in this example, we can see that we're calculating access between a CubeSat satellite and a ground station in Cambridge, Massachusetts, hopefully on our new engineering building that's going to come up. And we just want to see at what time intervals we can actually communicate between the two. So with the data that we send over with these communication lines, we can figure out if our payload was properly deployed and if it's actually collecting enough solar power / energy that is beneficial for the satellite. And note about this, our payload is specific to our cube satellite itself. So if you want to learn more about the really cool specifics about that, definitely check out our NITNOV video here on the top right. Well, now on to our second example. We are going to look at solar power generation. Buzz buzz. So with that same model, we can see how well our CubeSat generates solar power using the panels located all over the bus. If you look at the image on the top right, you can see that there's solar panels usually around almost every surface of the small lower cube. So looking at this, now looking at this graph on the right, we can see that over this several day period, there are various peaks of concentrated solar power generated depending on how the satellite is positioned along its orbit. If it sees the sun, it generates power. When it's on the other side of the Earth, it does not generate any solar power. And this graph specifically focuses on the effective areas of the solar panel. So if you wanted to go a bit deeper, you could tell if the Z-plane solar panels are generating a lot more solar power compared to X and Y. And you can see which ones are actually pretty more effective on that side. So it can get very, very, very into the details if you would like to. So now you can tell SCA is pretty awesome, but a little note / caveat. You have to remember it's still a mission level modeling software. So if you don't have the best data on initial points of where your satellite should be, it won't provide exactly the same results that happens in space. It's a great tool for starting out and understanding how all the different components of your mission will be interacting and working on after launch. But it's definitely our estimates, mathematical estimates. So it's definitely on the, I guess, make sure you got to check in real life hardware kind of deal there. So what did we learn? STK is really cool. You should use it. I think I've said that so many times already. The capabilities are sort of limitless. You got to explore to see what data is most useful for you to obtain from simulations to help you plan for your specific missions. STK also has incredible resources for training videos, as well as other just resources on learning how to use STK itself. They even have a whole section on small satellites, so definitely check those out too if you're a college CubeSat team like us. So lots of cool stuff there. And STK is also used in a lot of professional settings within defense companies and other space system groups, so it cannot hurt to try to learn STK and have it as an extra skill underneath your belt, or maybe your future career. So for now, thank you for watching this video, and hope to see you again on another Satellite Sunday.